Yeah, what we have here is lapping, then overlapping and underlapping of reinforcements in construction, and how it affects structures. So because you tend to determine your lap length during your design, so you know how the length of your reinforcement lapping is going to be. So this particular topic is very important in construction because it helps you to know how lapping tends to affect your structure, then how overlapping also affects your structure, then underlapping of your reinforcements, how it affects your structure. So from our first point, we have the introduction, which helps to define lapping, overlapping and underlapping of reinforcement. Refers to the splicing of reinforcement bar, where two or more bars are joined by overlapping their length to transfer the loads from one bolt to another through bonds. So whereby you just join your reinforcements together. Sometimes you can use your binding wire to do your lapping, sometimes you can use your bolt and nut, and sometimes you can actually do a welding procedure. So the purpose of lapping is to ensure continuity of reinforcement. So you do lapping so that there will be that continuity of reinforcement, then maintain structural integrity. So you do lapping so that you can ascertain the structural integrity of that structure and to prevent failure and critical sections. So you tend to do lapping to prevent failure at critical section. We have engineering application. So we have commonly used in beams because where do you have lapping, of reinforcement? So commonly used in beams. Then we also have lapping in columns. Then we have in slabs. We have in footings. We have in your walls. Then and other reinforced concrete elements, and where full length bars are not available. So where you don't have a full length bar, so you can just introduce your lapping so that you merge two reinforcements together either by using of your bolt and nut, your binding wire, and either by electrical welding, right? So lapping of reinforcement is done for continuity. So for you to just continue the reinforcement if you are not having enough reinforcement to reach the length that is required. Then it is also done for strength, for you to be able to attain the desirable strength. Then it is also done for safety, right? Then also durability of the structure. So you do lapping for you to attain that durability of the structure. Then it also helps you to economize, you understand, when you are constructing, instead of having maybe two different rods lying on the site as wastage. You can just merge them together, and considering the lap length, utilize such reinforcement. So we have the classification and types. So we have the lapping end to end, that is the split types of lapping. Then we have overlapping, that is staggered splits. Then we have underlapping, that is inadequate lapping, which is still split. So if you check the way it is, you can see the lap length of each of the reinforcements that are joined together. So for overlapping, you can see how you have excess reinforcement. Then for underlapping, you can see how the reinforcement is being managed. Then we have primary application. So for lapping end to end, you can see it is being used on your beams, your columns, your slab, your footing, and in tension zone. Then for your overlapping, you can see it's a long member with multiple bars, where staggering is possible. Then for the underlapping, it occur in poorly detailed or rushed construction. So where the construction procedure is not well organized. So for the advantages of lapping end to end, it is simple to execute, then common practice, then cost effective, that is for your lapping end to end. Then for overlapping, reduces congestion, then better stress transfer. That is, it actually helps you to transfer your stress, in a better way. Then improves durability, right? Yeah, so we also have the limitation. So for your lapping end to end, it requires adequate lap length, then congestion risk. Then for your other type of lapping, it needs careful detailing. Then more layout planning. So you need more layout planning, and it also requires more detailing. Then for the other one, we have weak bond, then high failure risk, then net code compliance. So you have that high failure risk for the other type of lapping. You understand? So lapping is very, very essential in construction. For number three, we have the common problems associated with lapping, whereby we have the lapping types, where the first one is lapping, then overlapping, underlapping. So we have the common effects. So for the lapping, we have insufficient lap length. So insufficient lap length is one of the common effects. Then poor bond, right? Then we have skip at lap joint. Then for the overlapping, we have congested bars, then uneven spacing, inadequate corners. So these are just the effects on overlapping. Then for the underlapping, very short lap. So the lap length is short, then no proper spacing or spacing, then misplaced bar. So these are just the effects the on the lapping. So we have the causes. So for the lapping, we have incorrect design. That is some of the causes for this lapping, overlapping, and underlapping. So for you to have your normal lapping, so the one of the causes there is the incorrect design, and we have poor workmanship. So if your artisan is not good with his craft, so it becomes very, very difficult for him to put the best out. You understand? So it's very, very imperative for you to get a very good artisan that understands the craft and how to put out his best. Then we have for the overlapping, we have poor layout, right? Then we have lack of supervision, because how will you tend to do overlapping on site if there is proper supervision? Then we have reinforcement congestion. So when you have inadequate planning, it usually tends to lead to poor construction practice. So you have to do proper supervision and proper planning for every construction work. Then for the underlapping, we have design error. Sometimes maybe during the design procedure and everything, there is a design error. Then cutting bars short. Sometimes your iron bender will want to cut for maybe this particular reinforcement. It tends to mix up the reinforcement and end up cutting bars short, or maybe due to measurement error in measurement can actually lead to cutting bars short. Then lack of inspection. So most of the jobs has to be inspected, because through thorough supervision and inspection, you see that merely looking at you on site helps them to do the right thing sometimes, right? Then we have failure mechanism. For the failure mechanism for the lapping, we have bond failure. That means where you lapped the both reinforcements, there can be bond failure. Then bar slip. So you can have still maybe at the edge, or maybe at where the lapping occurred, you can have a bar slipping off the other reinforcement bar. Then you can have crack propagation. So all these are still one of the failure mechanism. So the other thing is stress concentration, because the area whereby the lapping occur, that is the overlapping occur, you tend to have stress concentration. Then we have also poor compaction, because if maybe you did lapping, so the area where the lapping occurred has to be compacted very well, right? Then if it is not compacted very well, you can see it can actually lead to honeycombing, whereby you see all those honeycombs on your cast concrete. Then so we have the next one to be intermediate slip. Then we have sudden fracture, that is maybe during your casting, you tend to be seeing your cracks and fracture on the concrete surface. So because of the lapping that has been taking place, then we have brittle fracture. So all forms of fracture tends to occur. Then we have the warning signs. So what are those warning signs that you tend to see because of lapping? So we have cracks, that is cracks at the lap zone. So the area where the lapping tends to occur, you're going to be seeing cracks. So those cracks are due to warning. That is a warning sign that an improper lapping has been done. Then deflection increases, so you are going to have increase in deflection. Then you also have bar exposure, right? Then you also have voids in concrete. So this is for the overlap. You are going to have voids in concrete. Then honeycomb zones, so you're going to have honeycomb zones. Then we are going to have rust. So rust stains, you're going to have rust stains. That is still for overlapping. Then for the underlapping, you're going to have sudden wide crack. Then you are going to have bar pull out. Then you are going to have structural distress. So for the underlapping, so these are the warnings, signs that you're going to be seeing from your lapping, either being the normal lapping, the overlapping, or the underlapping. Yeah, then we have engineering risk. So because what are those engineering risks that are obtainable from your lapping? Because on site you see people just tend to do lapping, but they don't understand the engineering risks involved in lapping. So for the lapping, you have reduced length, then ductility loss, then possible collapse. So that is for your lapping. You have this three engineering risks. Then for the overlapping, you have reduced durability corrosion, right? So then we have serviceability issues. So you're going to have serviceability issues, reduced durability corrosion. Then for your underlapping, we are going to have sudden failure, right? Then collapse risk, then life hazards. So there's going to be threat to life. You understand? Because a building can suddenly collapse, which is the greatest risk in construction. So for the construction challenges, which is number 4, so those challenges that can be seen, that are visible, with lap length, is reinforcement congestion. So you're going to have reinforcement congestion, then accurate measurement of lap length, right? Because as maybe an engineer or a an artisan on site, so you must ensure that your measurements are accurate. Even if you're going to consider making use of your lapping method, you understand, for your reinforcement continuation, you're going to make sure that you do accurate measurement of lap length, then proper bar alignment. So your alignment should be done properly. You should also consider your alignment. In most of your construction work, your alignment is very, very important. Then concrete placement difficulty. Yes, because if your lap length is not rightly done, then placement of concrete becomes difficult. So even when you're using your poker vibrator, when it vibrates your formwork, you're going to see that your reinforcement is going to lose, because the lapping is not rightly done. Then inadequate cover maintenance. Yeah, so concrete cover is essential in construction. So it is very, very important you take note of your concrete cover in construction. Then work at height and safety risk. So this is very very important because anything safety is one of those essential things to look out for in construction. So it is very very imperative you take note of all the safety guidelines, and frequently have talks with your safety engineer for direction, right? Yeah, another construction challenge is lack of skilled labor. So sometimes even the skilled professionals you feel you have on site are not as skillful as you feel they should be. So, and this is a very big challenge in construction. Then we have our inspection and quality control issues. Both your quality assessment and quality control are very very important in construction, and if you're not having a good quality control officer, they will overlook the important things and start chasing the things that are less important, whereas it is not done that way. So you need a very good inspection and quality control officer on site. Then weather condition, rain and heat. So weather condition is very very important because it affects your storage on site, where you store your cement, your pop cement, and so on and so forth. So if the weather is not right, sometimes it affects your construction. Then material handling and storage, exactly. So if you do not have a good storekeeper on site that has been in the business, that understands the nitty-gritty of the construction procedure, it becomes a very very big challenge for you, because you start having lots of items, lots of materials, and all those things. Then we have construction delays and cost overturn. So every delay in construction, before they will tell you the cost of cement has increased, or the cost of this material has increased. So there's a time frame for every construction, and it is very very important that cancel out delay, face the construction, make sure you get the right things done, right? Yeah, the next thing we have is design and detailing complexity. So you must ensure the structural engineers handling your design did the right design, the code of practice is used, and all those things that are essential for the design, be it your foundation, your column, your soil test, all those things. You must ensure they pass through the right hands, good professionals that understands the job. So where you have clarity, they tends to give you professional advice pertaining to the job. Yeah, the next thing we have is an engineering solution. So for the engineering solution, which is number 5, we have the first one: provide adequate lap length as per code. So there are codes that actually teaches how, or explain how you go about your lapping. So always ensure you follow the right engineering code for your lap length. If it is your beam, your column, your slab, your stand, so even in foundation, if you're considering lapping in foundation, there are codes you use. And then we have stagger laps, overlaps bar properly. So you need to actually ensure that your laps length is considered, and your overlaps are properly done. Then we have use bar support to maintain cover. So where you need to ensure bar support, you tend to make use of bar support. Then we have ensure proper bar alignment. Yes, if you are considering lapping of your reinforcements together, so it is always good you ensure your bars are aligned. You understand? You consider your alignment very very well, which is very imperative. Then use high quality reinforcement. Yeah, this is where some engineers got it wrong. They tend to just buy whatsoever reinforcement they see and use it just to earn more, but this is not rightly done. You need to actually use the high quality reinforcements. Then proper concrete compaction. Yeah, you doing concreting, it is also important for you to ensure that you do proper concrete compaction. So this compaction is done to help your concrete fill all the voids, so that you can get the best concreting. Then we have regular inspection and supervision. So it is very very imperative for you to do the right checks, do the proper inspection and also supervise, all those ascribed to you to supervise. Then train skilled workers. Yeah, aside from getting people to work for you, it is also very, very important for you to, train your workers. Let them know what to do. Let them know the areas of job that will be ascribed to them, and the roles that will be ascribed to them, and how they are going to go about such roles. Yeah, the next thing is to follow standard detailing. Whereas we have our AS, our BS, our IS. So these are codes. So it is very, very important you follow these codes, so that it helps to guide you on some of these construction practices. Yeah, the next thing is to use couplers where lap length is limited. So where you have limited lap length, it is very, very important you use couplers to join two or more reinforcements, because couplers are designed to help you extend your reinforcement. So whereby maybe the lap length is short, you can just make use of couplers to increase the length of your reinforcement, because the couplers are also carrying the strength of the reinforcement. Then we have weather protection, for where you have your cement, your items, materials that can be destroyed by rain or other things. You can actually use weather protection. Then documentation and quality record. So every construction site should have a proper recording habit, because everything is money and every money should be accounted for. So it is very, very important for you to do proper documentation, and keep quality records. So we have the advantages. So the advantages of this is ensures continuity of steel reinforcement. That is the advantages of lapping. So it ensures that continuity of your steel reinforcement, and it helps to maintain structural strength and stability, right? Then allows flexibility in bar procurement and handling. So it also helps you to understand the procurement procedure and also handling of your reinforcements. Then it improves constructability in long members. So some members are long, so it helps you to actually improve that constructability in long members. Then cost effective and widely accepted method. So ensure durability when properly executed. Then it helps to reduce risk of sudden brittle failure. Then complies with engineering standards. So this is very, very important. So it helps you to comply with all the engineering standards and codes. So we have the economic and social impact. So for the economic and social impact, first it reduces construction cost. So the overall construction cost, it reduces it. Then through proper material use and waste reduction. So it helps you to get proper material use and also reduce waste. Then create jobs for skilled and unskilled construction workers. So it helps to create jobs both for skilled and unskilled workers. Then supports infrastructural development and urban growth. Then it improves safety and reliability of building and bridges. Then increases proper value and investor confidence. Yeah, gives value and also helps to improve investors confidence, right? Then minimizes maintenance costs through durable structures. Yeah, so you can read number 8 and 9 for yourself, but for number 10 it is very, very important. So we take it points after points. Adequate lap length will give strong bend and safety. So adequate lap length helps you to get safety. Then proper overlap reduces congestion and risk. So if you have proper overlap, it helps to reduce the congestion and also the risk. Then underlapping leads to weak bonds and failure. Then we have good workmanship plus inspection, tends to give reliable structure. Then follow standards, details, and best practice to stay away from failure. Then small mistakes in splicing can cause big failure. So all this is a comprehensive guide on lapping of reinforcements.